Welcome. On behalf of the MODUS Consortium, I would like to present you the second screencast in the series of screencasts describing the functionalities and uses of the different parts of the MODUS toolset. During this screencast, will be presented the first version of the hardware-software co-simulation module of the MODUS toolset. During the presentation, we will present you the different steps of the MODUS hardware-software co-simulation flow applied to a simple scenario. This will cover the UML-based modeling of the architecture of the system, relying on both composite structure diagrams and the UML marked profile, the generation of the System C virtual platform from the provided model, the configuration of the generated virtual platform covering the integration of IP blocks into the generated virtual platform, and the configuration of the parameters of the platform. Finally, we will compile the virtual platform and present some simple results of the simulation. But now, let's introduce a case study on which will be based this presentation. In this scenario, our target is a Xilinx-based system. It's comprised of a micro-based processor, a VRAM memory, which is a kind of static RAM, MDM components, which is a debug component including UART functionalities, and a bus component figuring the actual AXI and NMB buses of the system. On the top of the wall, a simple Hello World software is running, sending its messages to the MDM output. This Hello World software has been provided as binary, compiled for the real target. The objective is to reproduce the behavior of the real target and obtain relevant information. Now let's start with the first step of our design flow, the modeling of the architecture of the system. This is done within Papyrus, which is a graphical modeling environment integrated into the Eclipse IDE. It is well suited for the job because it allows the creation of composite structure diagram, and it can be used along with the marked profile and its hardware logical subprofile. This is of particular interest for us because the modeling of our system will be based on the composite structure diagrams and the marked stereotypes. Within Papyrus, a model is done easily in a drag and drop fashion. You can add, for instance, classes, ports, and we can apply stereotypes to these elements. Here we choose to apply the hardware processor stereotypes for our class, and to apply the hardware endpoint stereotype for our port. Of course, the interest of that kind of diagram is to model the internal structure of elements, which can be done also in a drag and drop fashion easily. For the purpose of this demonstration, we have prepared a model of our target system. This model is made of two diagrams. In the first one, we describe our bus with its sets of hardware endpoints, our processor with its own hardware endpoint, our VRAM, and our MDM. The last class of the model is a system, which is described in the second diagram. Here we have the internal structure of our system with the different elements connected to the bus. through the hardware endpoints and connectors. Now, the following step is the generation of the virtual platform. This can be done easily by selecting the action corresponding to the hardware-software co-simulation module. In a few seconds, we've got a set of generated files. One file has been generated for each class of the model. And also, we've got some specific files used by the virtual platform. Let's have a look to one of the generated files, for instance, the MDM. We see that we've got a portion of code to be completed by users, and we've got also some specific functions that have been generated to be implemented by users to implement the behavior of the components. This is also true for the microblaze. We've got a specific processor thread function to be implemented by users. When looking at the system file, we see the overall system implementation and some configuration parameters to be modified by users. That parameters can be, for instance, linked to the memory map of the system. We also have some user-specific portion of code. Now the configuration parameters must be set, and the user portion of code must be populated, which is what we call the configuration of the platform. This configuration has been prepared for the purpose of the demonstration. For the configuration, we have been using third-party IP for the implementation of the microblaze processor. We are also using the input Hello World software of the demonstration. When looking now at the MDM file, we see the declaration of the registers of the component into the user portion of code. We see also the initialization and the implementation of the read command function and the write command function. The write command function will be used during the demonstration to output to the console the characters sent to the MDM component. When looking at the microblaze, we see into the processor thread function the implementation of the behavior of the microblaze using the microblaze ISS third-party IP. Now the last steps are the compilation and simulation of the virtual platform, which is done within Eclipse with the CDT plugin, which is used for C development. Launch build. Build is OK. We can now launch the application. And we see the Hello World output into the console, which shows that the application is working properly. A file has also been generated, This file is used to collect statistics about the simulation. Here we have accounts of the access from microblaze to VRAM or MDM, and we see, for instance, 26 access to the MDM, which corresponds to the hello world output.